Okay, do you have any questions?
I don't think so.
Okay, we're going to start some chapter 4 homework. That's going to help you with the lab.
Okay, perfect.
I'm going to go over the lab very quickly, just so that you can see what it's about. So I'm going to change to the my browser. So I'm not sure what section you're in, but if you're in section 52 or in section 53, so I'm going back and forth between 52 and 53 right now.
Okay.
So in 52,
I'm in 52.
if you go to module 4, whoops, too far, which is stoichiometry essentially.
That's how you say it.
Yep. We've got the confer Zoom session links. So this is, the links to get into here.
Right.
The PowerPoint slides, the video lectures, the homework. I need to edit the homework real quick.
Okay. I'm in class. Okay.
So the homework actually has a due date, and we're not going to count this towards your .0 points. Do not count this. No file uploads. No submission. Assigned to everybody. What should we make the due date? Not February 4th, that's in the past. We'll make it next week, Wednesday.
Okay.
Or no, next week, Friday, which is the 5th.
I was going to say, it's not 26th yet.
Available from and until, we'll make it good until May 14th. And available from today. Okay, save that sucker. Okay, so if we go back to module 4. So we've got the confer Zoom links.
Right.
The PowerPoint, the lectures, the homework, which is worth 0 points, and then the lab, formula of a compound from combining masses. These other 2 labs I'll be working on, and we'll be adding them shortly.
Okay.
The quiz has to be done by next week on Wednesday, or no, Friday. And then there's your stoichiometry discussion, which is basically continue working on your 3x5 card.
Okay.
Okay, so let's take a look at the lab real quick. Now, I'm not sure if I'm recording this or not.
You are.
I am?
Yeah.
Okay, so let's take a look at the lab real quick. So here it's, when you go to the lab, you'll notice it says submit images of the lab right up from your lab notebook, all relevant sections. And then there's a link that you have to follow.
Okay.
And in that link, you'll notice it says file not found, but apparently now it has found it. Okay, so here's the lab itself. There's the background. Let's see. There's the background. And I'm going to keep scrolling. Here's the procedure. And here's, tells you about the data, calculations, results, and discussion. And then there are photos of the lab. Now, the reason there are photos of the lab is because this lab requires an immense amount of heat, as you can see in the photos here.
Okay.
And it's not a safe thing for people to do at home. So I did it in the lab at school, and I took photos of what was going on. at every process. And you can see what it says about what I've done before each thing. And from the photos, you're supposed to get all the data that you need to be
Okay.
able to do the lab.
So we don't actually have to do anything on our end. We're just supposed to go off of the worksheet, correct?
There is no real worksheet here. There's calculations.
Well,
so based on the
Question.
background, you're supposed to be able to calculate the formula of this compound.
okay.
And you want to discuss, your results. So here, there's no assignment added to this.
Okay.
Normally, I do include an assignment to get people to think about, well, what are the things I need to discuss?
Okay.
So this basically shows you how to go through doing something like this. All right. So that being said, I'm going to go ahead and close that window. If I can find, I need a bigger monitor. Okay, I'm going to close that. And I'm going to change my share screen to my desktop. I'm going to zoom in. A little too far. Come on. There we go. And now I need to get this thing to focus. Okay, so what I'm going to do then is I'm going to go ahead and start some chapter 4 material. So in chapter 4, the title is Stoichiometry, Quantitative Information about Chemical Reactions. So we'll go ahead and get started with some of this chapter 4 stuff.
Okay.
So here we go. What mass of HCl in grams is required to react with 0.750 grams of aluminum hydroxide? What mass of water in grams is produced? So you'll notice here that we have a balanced reaction. One aluminum, 3 oxygens here and 3 oxygens here, 3 hydrogens here and 3 hydrogens here for 6 total, and 6 hydrogens here, 3 chlorines and 3 chlorines. So it's a balanced reaction. Now I want you to recall that these coefficients mean the following: 1 mole of aluminum hydroxide is equal to 3 mole of HCl is equal to 1 mole of aluminum chloride and is equal to 3 mole of water. So that's what the coefficients mean. And you want to get used to this idea that 1 equals 3 equals 1 equals 3, but moles. Now they want to know what mass of HCl in grams is required to react with 0.750 grams of aluminum hydroxide. So the idea here is we're going to take that 0.750 grams of aluminum hydroxide and we're going to convert that into moles of aluminum hydroxide. Now, the reason we're going to convert that into moles of aluminum hydroxide is that these coefficients are the bridge between the amount of aluminum hydroxide and the amount of HCl. So you can see that this is the bridge right here. So we can go from moles of aluminum hydroxide to moles of HCl. And finally, we can go from moles of HCl to grams of HCl. So this is your basic stoichiometry type problem where you start with grams of A, You turn that into moles of A, and then you turn that into moles of B, and then you get grams of B. Now, how do we convert from grams of A to moles of A? Well, for this, you need the molar mass of A. How do you convert from moles of A to moles of B? Well, here you need the balanced reaction. And how do you go from moles of B to grams of B? Well, you need the molar mass of B. So to be able to do this problem, we're going to need the molar mass of aluminum hydroxide, and we're going to need the molar mass of HCl. So aluminum, oxygen, and hydrogen. Aluminum, you got 1 in that formula. Oxygens, you got 3, and hydrogens, you have 3. Hydrogens are 1.01 for 3.03. Oxygens are 16.00 for 48.00. And aluminums are, I want to say, are 26.98, and they are. So you've got 26.98. So we add these all up together and we get 1, 0, carry the 1. 3 plus 7 is 10, 18, carry the 1, and we got 78.01. And for HCl, we've got 1 hydrogen, 1 chlorine. Hydrogen is 1.01. Chlorine is 35.45. So altogether this way is 36.46. Okay, so we have our molar masses, we have the balanced reaction, and we have our directions, as it were. So let's see how we do this. So 0.750 grams of aluminum hydroxide times the molar mass of aluminum hydroxide. I'm going to put 1 mole of aluminum hydroxide on top and 78.01 grams on the bottom. So for this molar mass, I put the grams on the bottom so that they cancel. So next, I'm going to use my balanced reaction. So I'm going to use moles of HCl and moles of aluminum hydroxide. And I'm going to put moles of aluminum hydroxide on the bottom. And I'm going to put moles of HCl on the top. And that way my moles of aluminum hydroxide cancel. And then I'm going to multiply by the molar mass of HCl. Only this time for the molar mass, I'm going to put the grams on top because I want the moles to cancel. So if we do this work, we're going to end up with 3 significant figures because of the 0.750. And if we estimate the answer, 36 goes into 78 about 2 times. 2 goes into 3, well, we'll just call that 3 halves. So 1.5 times 0.75 is going to be approximately 1.1 or 1.2. So the answer should be about 1.2 or 1.1. So 0.75 times 3 times 36.46 divided by 78.01, and I get 1.05. And that's grams of HCl. So this is the kind of work I'd expect to see for a problem like that. Now, this also asks, what mass of water in grams is produced? So if we start off with 0.750 grams of aluminum hydroxide, what is our pathway here? And the answer is, well, it's going to be the same as the other one, only instead of going from, well, I'll say that we're going to get moles of aluminum hydroxide first. So far, the pathway is exactly the same. But here they're asking about water, not HCl. So when I go from moles of aluminum hydroxide, what am I going to calculate? We're going to calculate moles of water because that's what they want.
Moles of water.
And then we're going to take the moles of water and turn that into what? Grams of water.
Grams of water.
So the molar mass of water is 18.02 grams. The coefficients here we can see are 1 aluminum hydroxide and 3 water, right? So this is going to look a lot like the other reaction or other calculation. So there's the first conversion. I'm going to put a 1 here and a 1 here so that we can see they match up. I'm going to put a 2 here and a 2 here. So what am I going to use for my second conversion?
Moles of water and grams of water. Oh wait,
Oh,
sorry. 1 mole of H2O over 1 mole of AlOH3.
are you sure you want to use 1 and 1?
No.
What
1
do
and
we want?
3.
We want 3 mole of H2O
3 moles.
and 1 mole of aluminum hydroxide. So now that you've made that mistake once, you probably are less likely to make it again.
Yay.
And then what do we multiply by here?
The grams of water over 3 moles of water. So 18.02 grams.
Not 3, 1.
Oh, okay.
So we don't use the coefficients for molar masses.
Right.
Where do we use the coefficients? Right here. Doesn't it make sense that we don't want to use a 3 here because 1 mole of water is 18.02 grams, correct?
Right.
So if we used a 3 here, we'd have to use 3 times 18 up there.
Right.
So now that you've made that mistake, you probably are less likely to make that in the future.
Yay.
So here you can see that the outcome is going to be a little bit different because 18 will go into 78 about 4 times. 4 will go into 0.75 about 0.2 times, and 0.2 times 3 is 0.6. So before we got like 1.1, now we should get about 0.6 or 0.5. And we get 0.520 grams of H2O. Okay, so let's do one more calculation. We're going to start with 0.750 grams of aluminum hydroxide.
Okay, give me just 1 second.
Sure.
Okay.
Okay, so now we're going to start with 0.750 grams of aluminum hydroxide. And I want to calculate the grams of HCl that I need to react with it. So what would my pathway be?
The same as the first one.
So be more descriptive. So what am I going to change grams of aluminum hydroxide into? Or what am I going to convert it into? So look at what we did above. We took the grams and turned them into what?
Moles.
So what am I going to do here?
You're going to turn it into a mole. So the same as step one.
That's right. Now, what am I going to turn moles of aluminum hydroxide to if I want grams of HCl?
To moles of HCl.
Right. And then can we go from moles of HCl to grams of HCl?
Yes.
Okay. And actually, we did that problem. You see that?
That's why I was kind of confused. I was like, wait, didn't we do that already?
So let's change that and let's go from grams of aluminum hydroxide. And I want to know how many grams of aluminum chloride we make.
Okay.
So what are my steps here? What do I convert grams of aluminum hydroxide to?
Moles of aluminum hydroxide.
And then what do we convert that to?
Moles of AlCl3.
Okay. And then what do we convert that to?
Grams.
Now we do need the molar mass of aluminum chloride. I'm going to get it real quick. It's 35.45 times 3. And then plus your 26.98 for the aluminum. So this guy has a molar mass of 133.33 grams. So we're going to go 0.750 grams of aluminum hydroxide times what?
Times 1 mole over 78.1 grams.
Okay. 0.01 grams.
Yeah.
And then times what? Here's the balanced reaction.
Can you repeat that question? Sorry, my kids are being kids.
And then what do we put next?
3 moles of AlCl3 over 1 mole of AlOH3.
Well, let's take a look. Where do we find the correct numbers to use?
In my notes.
You find them in the balanced reaction.
Balanced reaction.
So what's the ratio?
1 to 1.
Yeah. So
Okay.
remember how we wrote this out at the very beginning?
Right.
So this says 1 mole to 1 mole.
Okay.
Okay. So I'm going to put the 1 mole of aluminum hydroxide on the bottom.
Right.
And the 1 mole of aluminum chloride on the top. Now what do we multiply by?
By 133.33 grams.
That's right.
Over 1 mole.
And in this case, you can see that 78 goes into 133, almost 2 times, but not quite.
Right.
So 2 times 0.75 would be 1.5. But since this doesn't go in 2 times, it's got to be less than 1.5, and maybe we say 1.3.
Okay.
Okay, let's see what the answer is. I get 1.28 grams of aluminum chloride. So in this reaction, we have 1.28 grams of aluminum chloride, 0.520 grams of H2O, and 1.05 grams of HCl. So in this reaction, where's the reaction? Ah, there it is. We calculated 1.05 grams of this stuff. We started off with 0.750 grams of this stuff. The aluminum chloride was, or the water was 0.520 grams. And the aluminum chloride we counted as being a 1.28 grams.
Yes, go to math. Go. Your homework's in the chair.
So if we add these two numbers together here, 1.28 and 0.520, we get 1.80. And if we add these two numbers together, we get 1.80. So this says that we took 1.80 grams of stuff and made 1.80 grams of stuff. Does that make sense?
Yeah.
Law of the conservation of matter. Okay, so that's your introduction to stoichiometry.
All right.
Let's take a look at this one here. So here we have another balanced reaction. What is the maximum mass of iron in grams that can be obtained from 454 grams of iron 3 oxide? So this is iron 3 oxide. Now, the reason they ask you for the maximum mass of iron is that when you do this reaction, you probably will not get the maximum amount of iron because something goes wrong. Like when you get this stuff, you probably have to purify it. When you purify it, you're going to lose a little bit of the iron.
Right.
Okay. So that's why they're asking you for the maximum mass. That maximum mass is also called the theoretical yield.
Okay.
So let's write that down for A. Maximum mass is the theoretical yield. And it's theoretical because in theory you could make that much, but in reality you probably don't. It's kind of like when you're following that recipe for Nestle's chocolate chip cookies and it says you're going to get 36 cookies. You don't, because you're eating dough as you make the stuff. Plus, maybe your cookie size is a little different.
Right.
Okay, so the maximum mass is the theoretical yield. Now we're going to do this the same way as we had done before. So what is the general method? Grams of A gets turned into what?
Into moles.
Right. And moles of A gets turned into what?
Moles of B.
And moles of B gets turned into what?
Grams of B.
Okay. So in this case, when they ask you, what is the maximum mass of iron? That's what we want to end up with, right?
Right.
So we want to get grams of iron, and that's there. So what does moles of B become in this particular problem?
Moles of iron.
Moles of iron. And it says from iron 3 oxide. So we're going to start out with grams of iron 3 oxide. And we're going to turn that into moles of what?
Of iron and O3.
iron 3 oxide.
Iron 3 oxide.
Okay, so there's our pathway. I'm going to call this 1, 2, and 3. What do we need to go from grams of iron 3 oxide to moles of iron 3 oxide in words? What do we need?
We need the molar mass.
Excellent. We need the molar mass of iron 3 oxide. So let's figure out what that is real quick.
All right, give me just a second. Sorry about that.
It's all right. So I did the work over here. It'll save us a little bit of time. Irons are 55.85, and there's 2 of them for a total of 111.70. Oxygens are 16.00, or 3 of them, that's 48. And when you total them, you get 159.70. So that's number 1. What are we going to use for number 2?
The ratio between iron 3 oxide and iron.
Right. What is that ratio? 1 mole of what? Iron 3 oxide
of iron 3 oxide
is equal to what?
Is equal to 2 moles of iron.
Exactly.
Okay.
And when I say exactly, I mean exactly. This is exact. So these have an infinite number of significant figures.
Okay.
And what are we going to use for 3?
The grams, or 1 mole of iron is equal to grams of iron.
Right. And that'd be 55.85 grams of iron.
Okay.
So we're ready to write out the solution here for A. We're going to start with 454 grams of iron 3 oxide. And how do you want to use this 159.70?
1 mole over 159.7 grams.
Okay, 1 mole though of iron 3 oxide.
Right.
Over 159.70 grams of iron 3 oxide. We don't want to leave
that part out.
Formula off.
Okay.
What's going to go next?
2 moles of iron over 1 mole of iron 3 oxide.
Yep. And then what are we going to put last?
55.85 grams of iron over 1 mole of iron.
Excellent. So you're picking this up very quickly here. That's great. Let's estimate the answer. How many times does 55.85 go into 159 approximately?
A little more than 3 times.
Okay, so let's say 3. So we have 2 divided by 3, which is 2/3, right?
Right.
What's 2/3 of 454? 300?
Yes.
So the answer should be around 300. We're going to get 4 significant figures because of this. Let's see what we get. $318. So that's your theoretical yield. Any questions about that?
Nope.
Okay, so now for B, it asks you what mass of CO is required to react with 454 grams of iron 3 oxide. So if A is about getting grams of iron and B is about carbon monoxide, what is the pathway for B? So we're going to start with grams of iron 3 oxide, and what are we going to convert that to?
You want to get my pencil?
There you go. To moles of iron 3 oxide.
Excellent. And what are we going to convert moles of iron 3 oxide to?
Moles of carbon monoxide.
Excellent, because now we're talking carbon monoxide, not iron. And then what are we going to convert that to?
Grams of carbon monoxide.
Grams of carbon monoxide. So for number one, we already have that 1 mole of iron 3 oxide is 159.70 grams of iron 3 oxide. What are we going to use for number two when we go from moles of iron 3 oxide to moles of carbon monoxide?
The molar mass of iron and
Nope.
no.
This one's molar mass.
Oh, right.
What's this one?
The ratio of moles of iron to moles, or iron dioxide to moles of carbon monoxide
Where do we find that ratio?
in the balanced equation.
Okay, so what is that ratio then, according to the balanced equation?
1 mole of iron 3 oxide to 3 moles of carbon monoxide.
It sounds like a question. How about making that an answer?
Okay, 1 mole of iron 3 oxide to 3 moles of carbon monoxide.
Correct. Whenever you say something like an answer, it will stick with you better than if you make it a question,
Okay.
even if you get it wrong. Okay, so we're going to say 1 mole of iron 3 oxide is equal to 3 mole of carbon monoxide. And where did we get that from?
From the balanced equation.
Excellent. And number 3, of course, is that 1 mole of carbon monoxide is equal to, carbon is 12.01, oxygen is 16.00, so that ends up being 28.01 grams. So we're going to start out with 454 grams of iron 3 oxide. And what do we multiply by?
1 mole of iron 3 oxide over 159.70 gram, or 0.70 grams of iron 3 oxide.
Excellent. What goes next?
2 moles of carbon monoxide over 1 mole of iron 3 oxide.
You sure it's 2?
3.
Do your 3s look like 2s?
No, my brain is just slow this morning and confused on numbers. Apparently my brain and numbers do not mix today.
And what goes last?
28.01 grams of carbon monoxide over 1 mole of carbon monoxide.
Okay, and the way I would do this is that 28 is kind of like 25, right? A little different, but close to 25. 25 will go into 100 4 times and then 62 more times. So this will go into that about 6 times, right?
Right.
3 divided by 6 is half. What's half of 454? 225?
225-ish.
Yeah, so 225-ish is what we expect for our answer. If our calculator spits out 2,225, we know we made a mistake, right?
Right.
and I get 238.8. Is that close enough to our 225-ish?
Yeah.
You bet your bippy. So 239 grams of carbon monoxide. And if we look at those numbers here, we have 239 grams of carbon monoxide, 318 grams of iron. So 318 grams of iron, 239 grams of carbon monoxide and 454 grams of iron 3 oxide. How many grams of CO2 are we going to make?
The difference between the added grams on the left.
Right. We have a little equation here.
Right.
We can see when we add these two together, we're going to get close to 700. And subtract that, the answer should be close to 400, but not quite 400. You know,
Right.
Maybe 350. Who knows? Right? So let's find out. $375. Now, this of course would be hard to weigh because it goes away as a smoke, right? Or not smoke, but as a gas.
Right.
But this would be a theoretical way to weigh it. Okay. So that's number 4. So let's take a look at number 6, and I'm going to have you do a little more work. So for A, how are we going to balance this reaction?
Look at.
1 barium, 1 barium, right?
Yeah, that's balanced.
2 chlorines, 1 chlorine.
Not balanced.
So what are you going to do?
Put a 2 on the right side.
Excellent. Okay, so now we have 1 silver and 2 silvers.
So you would put a 2 on the left side.
Okay. Sounds like we're getting into trouble here. Now we've got 2 nitrates. And over here, what do we have?
6.
2 nitrates.
Nitrates.
2.
Right.
So not 6.
Not
6
6.
oxygens, but not 6 nitrates. Okay?
Okay.
Okay, so we're balanced. 1, 2, 2, and 1, or another way to say it would be 1 mole, 2 mole, 2 mole, 1 mole. Say that with me. 1 mole,
1 mole, 2 mole,
mole.
2 mole, 1 mole.
There you go. Okay. So what mass of silver nitrate in grams is required for a complete reaction with 0.156 grams of barium chloride? You can see part B actually has 2 parts to it. So in this case, what are we going to start with?
0.156 grams of BaCl2.
And what are we going to turn that into?
Grams.
Actually, let me ask you this. What's the final thing we want?
Grams of AgNO3.
Okay, now the balanced reaction, the coefficients are moles, right? They're not grams.
Right.
So we can't go directly from grams to grams. What do we have to do?
Convert, or we have to go to 1 mole of BaCl2.
Well, let's not say 1 mole. Let's just say we
Mole.
want to find out how many moles of this there is.
Right.
And once we get that, what do we want to do with that?
Moles of AgNO3.
And then once we get that, what do we want to do?
Get to the end, which is grams of AgNO3.
Now, unsophisticated way of doing this would be to do 3 separate calculations. So the molar mass of barium chloride is 137.33 plus 35.45 plus 35.45. Well, that didn't work out. 137.33 plus 35.45 times 2. So this barium chloride is 208.23. This silver nitrate is, let's see, silver is 107.87. Nitrogen is 14.01, I think. Yep. And 3 oxygens is 48. So the silver nitrate is 169.88. Okay, so let's do this kind of the unsophisticated way. Our first calculation is 0.156 grams of barium chloride times 1 mole of barium chloride per 208.23 grams of barium chloride. So if we do this calculation, we get 0.00749 mole of barium chloride. So that's the first calculation. The second calculation would be 0.000749 mole of barium chloride times, according to the balanced reaction, 2 mole of silver nitrate to 1 mole of barium chloride. And so we would get 0.0014150 mole of aluminum nitrate. And then our third would be 0.00150 mole of aluminum nitrate or silver nitrate. Why am I saying aluminum? Because it says Ag. And times this 169 grams of silver nitrate per 1 mole of silver nitrate. And we get 0.255 grams of silver nitrate. So here's our answer, doing it kind of as 3 separate problems. Not very sophisticated. In Chem 1A, we're supposed to be sophisticated. So here, let's write out the sophisticated way. So what do we multiply the 0.15 grams of barium chloride by?
1 mole of barium chloride over 208.23 moles or grams of barium chloride.
Good. And then what do we multiply by next?
2 moles of AgNO3 over 1 mole of barium chloride.
Okay, and then what do we multiply by next?
169.88 grams of
Silver nitrate.
silver nitrate over 1 mole of silver nitrate.
And here, if we look at this calculation, we can see that this times this is 340. 340 divided by 208 is kind of like 3.4 divided by 2, which means it's almost 2. 2 times 0.156 is 0.3, but the answer should end up being a little less than 0.3, okay?
Okay.
And so let's see what we get. 0.156 times 2 times 169.88 divided by 208.23, and we get 0.255 grams of silver nitrate. And so here you can see that what we got is the same as what we got up here, but we have one nice solution. So this would be full credit, and this would be partial credit, because it's not enough to get the right answer. You need to show that you know how to go about doing this in a more sophisticated manner.
Okay.
Okay, so I would expect this on your exam for full credit, and this would only get you partial credit, because it
Okay.
shows that you just haven't put everything together. And this
Right.
does. Okay,
Okay.
so how about this one here? What mass of AgCl is produced? So I'm going to let you work that one out. And when you're done, give me a little holler, and I'm going to pause this for now.
Okay.
Let's see. How do I pause it?
That is a very good question.
Thank you. So I'm going to show you another way to get the pathway. You know you're starting with the 0.156 grams of barium chloride, and you know you're ending with grams of aluminum chloride, or silver chloride, I'm sorry. So to fill in the middle, it's simply going to be moles of barium chloride and moles of silver chloride.
Right.
So if you get the grams on the end, on the inside are moles and moles. And moles of what? Well, moles of barium chloride and moles of silver chloride. So if you know what the ends are, you know the insides are the moles of whatever's on the end. So we had the moles of barium chloride before. What was that? 208, 1 mole of barium chloride?
Yeah. 1 mole of barium chloride over 208.32 grams.
Over 208.32.
Yeah.
Okay. And what is the ratio of barium chloride to silver chloride?
Hold on. 2 moles of silver chloride to 1 mole of barium chloride.
Okay, because we had to balance the reaction, right?
Right. Okay, you can wait until I'm done.
And then what is the molar mass of silver chloride? What did you get?
I got 286.64 grams.
For silver chloride?
Yeah, which I could totally be wrong on.
I got 143.32 because silver's 107.87, right?
I know what I did. I multiplied by 2 when I shouldn't have.
Because of the balanced reaction.
Because of the balanced reaction.
So it's 107 or 143.32 grams of silver chloride
Right.
per 1 mole of silver chloride. Now, you know, your number would have worked if you wrote 86 over 2 moles, right?
Right.
But we don't do that. We just say 1 mole weighs this much.
Right.
So if you wrote that over 2 moles, technically be correct, but it wouldn't get full credit. So if we estimate the answer, 2 times 143 is almost 300. 300 divided by 200 is like 2/3 or 3 halves, which is 1.5. 1.5 times 0.156 makes that about 0.22 or something.
Right.
So how many zig figs are we allowed?
4,
Nope.
3,
Right, because of this.
because the 0 doesn't count.
Right, leading zeros never count.
Those always mess me up for some reason.
Well,
I've reminded myself of that a million times, but for some reason, when I see the 0, I think that's included.
but it's not. So I get 0.215 grams of silver chloride. And our estimate was like 0.22 or something like that.
Yeah.
Okay, so there you go. A lot of this chapter is this kind of stuff.
Okay.
All right, cool. Thanks for calling in.
Thank you.
Hopefully we'll see you tomorrow or this afternoon or whenever.
I will see you the next time I can make it.
Doodles.
I might try to jump on this afternoon just to get a little bit more practice.
Okay.
And then I'll definitely be here tomorrow.
All right. We'll catch you later.
Thank you.
You bet.